bites meet. The first bite asks, "Are you ill?" The second bite replies, "No, just feeling a bit off." Hey there, everybody. Welcome to episode number 532 of this here electronic engineering podcast called Amelia's Weekly Fish Fry, brought to you by eejournal.com and written, produced, and hosted by yours truly, Amelia Dalton. What have I got cooked up for you this week? Well, I'm talking about how you can shorten your development time and accelerate code across heterogeneous compute platforms with CacheQ CEO Clay Johnson. Clay and I explore the benefits of heterogeneous compute development, the details of CacheQ's QCC development platform, and what sets CacheQ's QCC development platform apart from open source tools. So, without further ado, please welcome Clay to Fish Fry. Hi, Clay. Thank you so much for joining me.
Hi, Amelia. It's nice to see you again.
Excellent. Okay, so when we last talked, CacheQ was introducing the QCC acceleration platform, and now it supports GPUs. So explain to my audience why the move.
Okay, so when we originally started the company, we're an acceleration company. So what we deliver to our customers is a platform for them to take standard high-level language and be able to take something like C, C++, run it through our platform, and get acceleration. And the way that we do that is we essentially target hardware platforms that we can run things in parallel. So when we originally introduced QCC, it was focused on FPGAs. We have a lot of experience in FPGAs, and we were able to take code and run things fully pipelined in FPGAs, which delivered significant amounts of acceleration. However, what's been going on in the market and our overall plan for a long time is to be able to support heterogeneous platforms, whether that's running multiple threads on a CPU, whether that's targeting an FPGA, or if you look at the market today, GPUs are getting a tremendous amount of traction. You just have to look at the amount of traction that NVIDIA is getting in the marketplace. So our core technology was architected so that we could support many different hardware platforms for acceleration. So it's just an evolution of our technology over time in that we took what we had previously introduced for multi-threading on CPUs and FPGAs and extended that to be able to support GPUs. The other thing that's exciting about that is that GPUs are getting a lot of traction in the marketplace in terms of the number of developers who are focusing on GPUs. Whether that's in the data center or even on the edge, GPUs are starting to be used in robotics and industrial and medical. So it's gaining a lot of momentum. So we look at that and say, okay, we can now offer a platform that can support a spectrum of end technologies. And depending on performance per watt, performance per dollar, users can take the same code and they can target any number of different acceleration platforms, giving them the optimal solution.
So, Clay, what do you think are the benefits of a heterogeneous compute development?
Well, so if you look at applications, there's a broad spectrum of applications that need acceleration. I already mentioned some. You can talk about at the edge robotics, industrial control, but you can also look at what's done in the data center in terms of like scientific computing. Whether that's computational chemistry, computational physics, immunology. There's a bunch of things that are done, I'll just loosely say, in the government that need acceleration, things like encryption and decryption. And there is no one size that fits all. There are still applications that run better multi-threaded on a CPU, simply because you have to be concerned with data movement, moving data between, for example, a CPU and a GPU accelerator. That takes time. So there are some things which just run multi-threaded better on a CPU. But then there is also a whole slew of applications where if I target them on the GPU, I'm going to get higher performance in terms of wall clock time, how long it takes to start and finish, or whether that's performance per dollar, any number of different metrics. And so there is a desire amongst customers to say, you know what, I'm not sure what the best solution here is. I could target a CPU, I could target a GPU, I could target an FPGA, or with some customers, they actually develop their own custom solutions. And so the desire there is, I don't want to get locked into a particular development platform, a development environment that makes me make that decision upfront. That says, okay, you know what? I think it might be the GPU, therefore I'm going to use CUDA from NVIDIA. But that might not be the best solution. So if you have a development platform that says, you know what, from the same source, I can target any number of different platforms from any number of different vendors. And then depending on the results, I can then make the decision based on the results. And I don't have to make that decision way up front. I don't have to spend a lot of time and energy figuring out all the details of the architecture, all the details of a particular vendor's tools, and I can get a really, really good indication what's going to be the best platform for me. For example, I might want to use, now NVIDIA is the leader in GPUs today, but AMD is a player in GPUs. So I don't want to necessarily get locked into NVIDIA. I might want to say, gee, AMD's coming out with these new GPUs. Can I target those GPUs? With our platform, you can target an AMD GPU, you can target an NVIDIA GPU, or for that matter, in the compute space, you can look at, x86 rules compute, right? But there are people who are making ARM servers. There are people who are developing RISC-V technology that's going to go after both edge and, the data center. So we are able to actually target x86. We can target ARM, like many core ARMs, or we've actually run our stuff on multi-core RISC-V already. So it gives the customer the ultimate level of flexibility to allow them to target any number of different platforms across any number of different vendors.
Excellent. So let's talk about those architectures. What other architectures does CacheQ support?
Well, so we support, as I mentioned earlier, multi-threading on CPUs. That's one. We support FPGAs from a number of different vendors. The number one vendor in the PGA space is Xilinx. And then we also support GPUs. And the main player in GPUs is NVIDIA. NVIDIA has a product line called Jetson, which is focused on embedded applications. We can support targeting Jetson all the way up to running on an A100, which is a high-end GPU predominantly used in the data center. And we can also target AMD technology. So we can target the MI class from AMD, MI100, MI200. AMD's recently announced the MI300. I'm sure we'll target that when that's actually has more availability in the marketplace.
So, Clay, why do you think software developers should choose the QCC acceleration platform and not an open source tool?
I'll say that's a good question. So if you look at open source tools today, predominantly what you'll see in this space is something called OpenMP or OpenACC. And what those are, what we call directive-based languages. So I take my code and I insert things into my code that says, okay, I want this loop to run in parallel, and I want it to run in parallel in this fashion. So it puts the onus on the user to figure out, okay, here are the loops or here are the portions of my code that I think can be accelerated. And for example, either run multi-threaded on a CPU, or in the case of something like OpenACC, it can target GPUs. So you have to figure that out. So the developer has to say, here's the portion of my code that I need to be accelerated. And then beyond that, they also have to figure out, here's the data and here's how I need to transfer data between, for example, the CPU and the GPU, right? So that onus is put on the user. The other thing that also requires is that the user is responsible to ensure that their code can actually run in parallel. Because if I'm running things in parallel, there's the potential to get data conflicts and race conditions. And when that happens, the results that I generate out of that code are incorrect. So you can take working serial code and you can run through, say, something like OpenMP or OpenACC, and you can put in all this work and figure out what needs to be run parallel. And the net result is it could run slower and it could produce the wrong result. All right. With our platform, we are not a directive-based platform. So we put in a lot of energy and our intellectual properties around being able to actually analyze code. So we go through and we do extensive analysis on code to figure out what loops can be accelerated and what loops can't be accelerated. Or translation of that, what loops can be run in parallel and which ones cannot. All right. And so once we do that, we report back to the user and say, okay, this loop here we can run in parallel, this one we can't, and this is the reason why we cannot. And that involves actually looking at code, analyzing code to figure out how we can actually take loops and run them in parallel. But beyond that, it's also looking at data and doing extensive pointer analysis to figure out if there's data conflicts. All right, if I have conflicts with two different pointers accessing the same data. And if you do that, you can create, as I mentioned earlier, you can create conditions where the code will actually not operate correctly. So it's a combination of thread analysis, pointer analysis, optimally moving data, and we do that automatically for the user, which is not what you get from open source tools.
So, what applications or markets is CacheQ finding a good fit in?
So there's a number of markets. One of them is what I call scientific computing, or what I mentioned earlier, computational chemistry. So that goes around pharmaceuticals, it goes around drug research, goes around analysis, for example, like blood analysis. So that's one market. The other market where we have traction is because of their compute needs. We have interest from, I'll just loosely say, government. And government is a space where it's fairly broad, but essentially they try to run things on servers and they need to run things on servers more quickly than they can get out of just running serial code. The other space where we are seeing traction is, I would just say, the whole industrial medical space, medical devices kind of stuff, which is more, I'll call it almost embedded. So you can look at something like medical imaging, stuff like that. And that's another space where we actually see a lot of traction. So it's a mixture. It's a mixture of things that run on the edge because there's this heterogeneous transformation that's been happening for a long time where you compute on the edge or you compute in the data center. Some things are predominantly or exclusively run in the data center, but there's also applications where it's a combination of things that run in the edge and actually run in the data center. Right? But most of our stuff, I would say, is it boils down to computationally intensive items on lots of data.
All right. So, where should my audience go for more information about CacheQ and the QCC acceleration platform?
Okay, so we have a website, CacheQ.net. You can just go up on our website. There's a number of training videos up there. There's a couple videos that actually go through there one of them is about 30 minutes. You can go through and it talks about the details of our technology. Our CTO actually does one of them. So that's a place to start to get information. Up there also, you have the ability to submit an email to us and it will come to us. And if you have questions, we can respond to it that way.
Excellent. All right. Clay, it is time for your off the cuff question. Now, I know you're a golfer. I'm a golfer too. So you get a two-part question here.
Okay.
Number one, what's better, your short game or your long game?
My long game is better than my short game, unfortunately. I think over time, my short game should get better than my long game because over time, my long game will get shorter and shorter.
That's true. And second question, where's the most fabulous place in the world that you've gone golfing?
Well, so I live in the Bay Area, and therefore I'm not too far from the Monterey Peninsula. So I played a number of courses down there. I played Pebble Beach, I played Spyglass, and I've actually also played Cypress.
Oh, nice.
So all of those are incredible experience from a golf point of view. I would say this is maybe contrary to other people. Out of the three, I actually like Spyglass. I think it's a fabulous golf course.
That's excellent. All right, Clay. I think that's all I have time for today. Thank you so much for joining me.
Absolutely. It's great seeing you again.
Well, folks, that's all I have for this week's Fish Fry. But you'll want to stay tuned in the coming weeks because I have some super fun episodes lined up, including an interview with Ambar Sakar, DAC 2023 Engineering Tracks Program Chair and Backend Design Track Chair, and Bryce Yonker, Executive Director and CEO of Grid Forward, a nonprofit organization that brings together utilities, solution providers, government agencies, regulators, and advocates to work together on making grid modernization a reality. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EE Journal. If you're into Twitter, you can monitor our tweets at EE Journal TFM. And don't forget, if you would like to follow my personal Twitter account, check out Amelia D 1978. And hey, if LinkedIn is more your thing, I dig it. You can follow us or me on LinkedIn as well. And we have a YouTube channel, youtube.com/EE Journal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series hosted by me. And you can subscribe to our EE Journal YouTube channel as well. Also, by clicking the links below the player on this week's Fish Fryin' page, you can subscribe to this here podcast through Spotify, Podbean, or Apple Podcasts. And remember, if you'd like to further support this podcast, please leave me a review on that podcasting platform of your choice. It really does help. Thank you, everyone, for tuning in. If you know of any cool new technology or heck you just want to chat, shoot me a line at Amelia, that's Amelia, at eejournal.com, or post a comment on our forums on EE Journal. For the week of May 19th, 2023. Oh, happy birthday, Mom. I'm Amelia Dalton, and you've been fried.